Hello everyone, welcome back to the session on trigonometry. If you remember, in the last session we did a couple of problems based on t ratios of specific angles, right? So today we continue with that topic. We do a few more problems in today's session. So let's get started. Let me share my screen. I hope you're able to see my screen. Okay, as I said, we'll continue with this topic on trigonometric ratios of specific angles. Let's go to the first problem of today's session. So this is the problem. It says if tan of 3x plus 30 degrees is equal to 1, find the value of x. So for your reference, I have given the table of values here, and the question says if tan of 3x plus 30 degrees is equal to 1, we need to find what x is. So when you get a problem of this kind, what is our approach going to be? If you look at this given condition, tan of a quantity, let's say 3x plus 30 degrees is, the whole thing is a. Okay, so tan of a is equal to 1, right? So that's what is given. Now, our objective would be to convert the right hand side, which is now showing as 1, in terms of tan. So if we can convert the right hand side in terms of tan, then you will have the left hand side as well as the right hand side having values of tan. I'll give you a hint here. If tan A is equal to tan B, if tan A is equal to tan B, we can say that A is equal to B. If tan A is equal to tan B, we can equate A and B. A is equal to B. That's what we are going to do here. So we are going to first convert that 1 in terms of tan. So how do we do it? Let's see. So the left hand side, we are not going to change anything there in the left hand side. So we will keep the left hand side as it is. So tan three x plus 30 degrees stays as it is, but we are going to convert 1 in terms of tan. Now, what is the value or what is the measure of the angle for which tan will give you an answer of 1? Is it tan 0? Is it tan 30? Is it tan 45? Is it tan 60? Or is it tan 90? And this is one of the most easiest values to remember. Tan 45 is equal to 1, which means cot 45 is also equal to 1 since cot is the inverse of tan. So that's the most easiest value in that whole table to remember. Tan 45 is equal to 1. So what we're going to do is, instead of saying 1, we are going to write it as tan 45 degrees. Now, whenever you mention something like this, you also need to mention why it is, since tan 45 is equal to 1. Right? So what do we have? We have now tan 3x plus 30 degrees is equal to tan 45. In the beginning, I just mentioned an example. If tan A is equal to tan B, we can say that A is equal to B. So that's what we're going to do here. Tan 3x plus 30 degrees. Let's consider 3x plus 30 degrees as A and tan 45 as B. So tan A is equal to tan B, A is equal to B, right? Therefore, 3x plus 30 degrees is equal to 45 degrees. This means 3x is equal to, taking the 30 degrees to the other side, 45 degrees minus 30 degrees. 3x is equal to 15 degrees. What is our question? Our question is to calculate the value of, find out the value of x. Right, so we've got 3x is equal to 30 degrees, which means x is equal to, so 3x is equal to 15 degrees. That means x is equal to 15 divided by 3, and that is x is equal to 5 degrees. So this is our answer. Simple question. All you have to do is convert the right hand side in terms of whatever is there on the left hand side. So left hand side is tan, so you have to convert that 1 into tan. Look for the angle which will, for which tan will give you an answer of 1. So that is tan 45. Once you do that, remember tan of A, if tan of A is equal to tan of B, it means A is equal to B. That's what we're doing here. Tan of 3x plus 30 degrees is equal to tan of 45. Hence we say 3x plus 30 degrees is equal to 45. 3x is equal to 45 minus 30. We get an answer of 15 for 3x, and from that x is equal to 5. So that's your first problem. Okay. Let's move to the next one. So here it says in triangle ABC, which is right angled at B, AB is given as 5 centimeter, angle ACB is 30 degrees, and the figure is given. Determine the lengths of the side BC and AC. So here we have a triangle, we have one side given, and we are supposed to find out the other two sides, right? So normally when you get one side, it's not possible to find out the other two sides. We need at least two sides, then we'll be able to find out the third side. But here there is another way, because instead of giving you a second side, they have given you an angle. So that is good enough for us. So we have one side and one angle, and with that we'll be able to find out the other two sides. So again, whenever you get a problem, first try and understand what is given, what is asked, and how are we going to approach this problem. So I need to find out from this, I need to find out the side BC and AC, right? I only have one side given, which is AB, and I have an angle. Now let's look at this. So in order to find out the lengths of the side BC and AC, how can you, or rather, if you look at the 30 degrees, this one, 30 degrees is given, 5 centimeter or AB is the side opposite to 30 degrees, right? So we have 30 degrees and we have a side that is opposite, one side that is opposite to 30 degrees is given. So now our next thing would be to find either BC or AC. You can, it's up to you, if you want to find BC, you can find BC, and then with the help of AB and BC, you can get the hypotenuse. Or you can find out what the hypotenuse is, and with the help of hypotenuse and 5 centimeter opposite side, we can find out what BC or the adjacent side is. So here I am going to consider angle C, and I'm going to look at opposite and hypotenuse. So opposite is AB, hypotenuse is AC. Okay, so just write it here. So in triangle ABC, right, which is right angle at B, you know that. Now, which is the relation, which is the trigonometric ratio that connects opposite and hypotenuse? It is sine, right? So you can say sine of angle C is equal to AB divided by AC. And from the table that we learned, we know that, okay, what is sine of C? We'll write that first. Sine of 30 degrees, because that is given, is equal to AB by AC. And here we are also given AB is equal to 5. We'll substitute that. But before that, sine of 30 degrees, what is sine of 30? Sine of 30 is 1 by 2 from the table. That is equal to AB is given as 5 centimeter, AC is not given, AC is what we're going to find out. Now cross multiplying, you get AC into 1 is equal to 5 into 2. So AC is equal to 10. So we got one side AC is equal to 10. So once you have AC is equal to 10, can't you find, I'm just writing it here, 10 centimeters. Now, in a right angle triangle, if two sides are given, can't we find out the third side? You can, right? And which theorem helps you to do that? It's Pythagoras theorem, right? So here, if I say by Pythagoras theorem, hypotenuse side AC squared is equal to the sum of squares of the other two sides. So AB squared plus BC squared. We just found out what is AC. AC is 10, so AC squared is 10 squared. AB was given in the question, it has 5, so 5 squared plus you have BC squared, which when simplified would give us 100. That is 10 squared is 100. 100 is equal to 25 plus BC squared. I'm writing this whole thing this side and this one this side, so it's 25 plus BC squared is equal to 100. Keeping BC squared here because that's what we want to find out, is equal to 100 minus 25, which is 75, right? So BC squared is equal to 75, but we need to find out what BC is. Therefore, BC is the square root of 75. Now we know that 75 is not a perfect square. So that means BC is equal to, we'll just split that 75 into factors. 5 into 5, 25 into 3 is 75, right? So that means BC is equal to 1, 5 comes out, and then we are left with the root 3. So that is your BC. BC is equal to 5 root 3. So we've got both the answers now. We've got here BC, which is 5 root 3. And earlier we found out what AC is. AC is 10. If you want, you can go and substitute that value here. 5 root 3 centimeters. So that's for this problem. Hope you're clear on this. Just to summarize, what we did is we were given just one side and one angle, and we were asked to find out the other two sides. But with that angle, we were able to get a relation between opposite and hypotenuse by using sine. We got the hypotenuse because we know the value of sine 30 is half. So with that, we equated half is equal to 5 divided by 10, opposite by hypotenuse. And from that, we found out the value of AC. So once you get AC, you already have AB. So two sides we've got now, and it was easy to find the third side by using Pythagoras theorem. So Pythagoras theorem, hypotenuse squared is equal to sum of squares of the other two sides. We did that and found out the BC side as 5 root 3. So that's how we got both the answers. So thanks for watching, and we will continue with another problem in the next session. Thank you.